Hi, I'm Guang, 50 years old. In this lesson on the techniques and applications of definite integration, we're taking a look at this question over here. In this question, we're supposed to find the volume of one of the wedges cut from the cylinder 4x squared plus y squared is equal to a squared by the planes z is equal to 0 and z is equal to my squared. Right. So firstly, we will have to take a look at what kind of integration are we going to have here. Now, since this is finding a volume and we are given x, y, and z, which means this is technically a triple integration over v, and you're going to have dv, alright? So, this is essentially what you have to think about. But for this part, you will also have to know whether integrate with respect to x first, with respect to y first, or z first. Right, so then again, we can continue to take a look at this question here. So what do you think about it? Now we do have a function of x and y, and a function of z and y. And then you realize there's a z is equal to 0 and the z is equal to my squared. So z is equal to 0 from your x or y plane. Z is equal to 0 to my squared depending on wherever it is, which means this is essentially your height. And this being your height, then you can determine that this can be used as your integrand since it is from 0 to my squared, which is basically integrate from 0 to my squared and then dz. So you can change this into, you integrate twice and you're going to have my squared. And next, all you have to determine is whether you want to integrate with respect to x first or y first. But for that, we're going to have to take a look at the first function, which is 4x squared plus y squared is equal to a squared. Now, this, you might not recognize the form yet, but we can change it a little bit. Well, we're going to have x over a over 2 squared plus y over a squared is equal to 1. So this function is essentially the same as 4x squared plus y squared is equal to a squared. Now, what is this function exactly? So this is a function for an ellipse. Here's your x-axis and y-axis. And along your y, you're going to have a and negative a. But along x, you're going to have a over 2 and negative a over 2. Right? So in this case, you're going to see something more of an ellipse. Right. So this is pretty much what your base area is like, or should I say, it's pretty much your entire volume. It's just that at the top of it, it is limited by z is equal to my squared. So what's so special about this? Now you might recognize this as an elliptic cylinder, since the base is of an ellipse and it's pretty much always an ellipse. So what exactly would be so special? Whether you want to integrate with respect to dx first or dy first is completely up to you. So whether you want to integrate with respect to x first or y first, then you have to change this accordingly. Now let's say we want to integrate with respect to y first. Now y, which means you're going to have to do it vertically, alright? So let's just say we do have a little area here. So for this little area, what you're going to have is, when you have an integrand, you do have a certain height above that small area above your section. And then when you integrate with respect to y, you will have one of these pieces here, and you integrate upwards. And after you find each of these bands, then you will have integrate with respect to x. We're going to have to add up all of these bands by bands, alright? So this entire thing is the area that we're going to have, right? So if you want to integrate with respect to y first, then we have to know what is the function for this part above and what is the function for the part below. So take a look at your original function. You can change it into y is equal to positive negative square root a square minus 4x square. So if you realize it, this will actually be your boundaries for y. Now how is it so? Now for y, when it is positive or negative, the above section, this section over here, this section is the positive. Well, above it will be y is equal to square root a square minus 4x square. So it's just for the above section. How about the below? Now the section below, you'll have y is equal to negative square root a square minus 4x square. Right, so that is how you can separate this into two different parts. Now that we can determine this integration, so it'll be from negative square root a square minus 4x square to square root a square minus 4x square. And your range for x would obviously be from leftmost side to rightmost side, which is negative a over 2 to a over 2. Alright, so this is what we are going to see. Next, we'll just have to start integrating it. Now, you just have to be aware when you're integrating with respect to y, m, you'll take it to be a constant, since m here will just be, well, you just take it as a constant. So you have m over 3 integrate from negative a over 2 to a over 2 y cubed, substitute in negative square root a square minus 4x square and square root a square minus 4x square. So then you have to be aware that both of these, where you have a, you'll take it to be just another constant, alright? So you have two constants here, one is a, one is m. Now you can just substitute in the two values. Well, if you realize, you just have times 2. Alright, so this is what you're going to see. But then you might be wondering, how are we going to solve this portion here? Of course, then you have to recap whatever you've learned before, where in this case, you have to think about a substitution. Now, there's certain kind of substitution. You take a look at the form again. It is something squared minus something x squared. So of course, it will be a trigonometric substitution. But what kind of trigonometric substitution? For this case, it will be sine or cosine. Alright, so you can just let x be, let's say, a over 2 sine theta. So when you have dx, you're going to have a over 2 cosine theta d theta. Right, and of course you need to know your range for theta. Since it's from negative a over 2 to a over 2, that means sine theta is from negative 1 to positive 1, which means this will be from negative half pi to half pi. Alright, so this is what we will see. Alright, so now that we can use this substitution, we are going to have 2m over a, substitute in, or should I say, integrate from negative half pi to half pi. Now, from this part inside, you're going to see a cubed. And so since you're going to have square root and you took the a square outside, which means you are just going to have cosine cube theta. Alright? And then when you change the dx, you're just going to have another a over 2 cosine theta d theta. Right. So next you just have to integrate this part. Well, you can once again take out all the constants, and you're going to have ma to the power of 4 and then over 3. So you have to integrate from negative half pi to half pi for cosine to the power of 4 theta d theta. Now, cosine to the power of 4 theta d theta. In this case, you will have to use your double angle formula. Now, in the double angle formula, you will need to multiply it by 2 squared, since you have 2 to the power of 4, and you have to separate it into cosine squared theta and another cosine squared theta. So you'll need ma to the power of 4 over 12. Then integrate from negative half pi to half pi, where you are going to see 1 plus cosine 2 theta and then squared. Then here you have d theta. So you can expand that to see ma to the power of 4 over 12, integrate from negative half pi to half pi d theta, plus ma to the power of 4 over 6, integrate from negative half pi to half pi, and cosine 2 theta d theta, and adding on ma to the power of 4 over 12, integrate from negative half pi to half pi cosine squared 2 theta d theta. Right, so we just have to integrate this part now. The first term should be rather simple to integrate, since what you will see is there will be half pi, so half pi minus negative half pi, that will just be a pi, where you're going to have ma to the power of 4 pi over 12. Now in the second term, so we're going to have to divide by 2, and cosine becomes sine. So you will see, add on ma to the power of 4 over 12 sine 2 theta, substitute negative half pi and half pi. Well, for your last term, you'll have to use the double angle formula once again to get plus ma to the power of 4 over 24, integrate from negative half pi to half pi, and then 1 plus cosine 4 theta d theta. Right. So the second term, since you have to substitute in half pi and negative half pi, when you put them inside, you're going to have sine pi and sine negative pi, which both give 0. So that you won't have the second term anymore. Well, for your last term, you are going to separate them once again. So you have ma to the power of 4 pi over 12, then add on ma to the power of 4 pi over 24. Since when you just have a d theta, you'll just have pi over 2 minus the negative half pi, which just have multiplied by pi. And the last term, we just add on ma to the power of 4 over 96 sine 4 theta, and you have to substitute in negative half pi and half pi. But likewise, when you put in half pi or negative half pi, you're going to have 2 pi and negative 2 pi, which are both 0. So here you will be seeing, so ma to the power of 4 pi over 8. Alright, so this is going to be the volume for this kind of wedge cut from this kind of elliptical cylinder, which is the volume is ma to the power of 4 pi over 8. Right, so what kind of processes did we use in this example here? Of course, first of all, you will have to know where are you integrating from, where are you integrating to, how are you going to integrate it first. Since we know that z is just bounded by z is equal to 0 and z is equal to my squared, we can quickly determine your integrand for a double integration. Well, you can leave it in a triple integration form at first and having integrate from 0 to my squared dz, but afterwards it will just be changed into this form. So from this part, we have a little bit of integration with m and a being constants, and afterwards you make a trigonometric substitution. You can choose to use sine, you can choose to use cosine, and for the previous part you can also choose to integrate with respect to x first and integrating with respect to y later on, but that just depends on you. Right, so after you make the trigonometric substitution, we will have to use the double angle formula twice before arriving at the final answer of ma to the power of 4 pi over 8. Right, so that is pretty much it for this example. I hope that you are clear of it so far. I'll be ending this here, and thank you for your watching.